spot, a place we like to call Shelburne Falls. There's a lot going on here and a lot that we need to talk about. I hope you can hear me over the falls. So, the rock you are standing on is called gneiss. See, we like it, so we call it gneiss. I don't know why it's called gneiss, but it is. Gneiss is a metamorphic rock that forms very deep within the earth. So the phase of Massachusetts history that this comes from is the collision phase, when all of those island arcs were being pushed into the side of North America. This rock was buried very, very deeply, buried 12 miles deep, in order to create the tremendous pressure and expose it to the massive amounts of heat that are necessary to make rock flow like taffy. If you look at the patterns of the rock over there, you will see that they took once level layers and they are flowing like taffy and re-hardening. So, the rock got buried. It got transformed, metamorphosed, this metamorphic gneiss. Then, I'm standing on it now, so clearly it got unburied. So what happened? Well, Pangea starts to break up, and erosion of the mountains starts to happen in a big way. The 12 miles of rock that was on top of this site has been eroded away. Some of it stayed here in the Connecticut River Valley and became the sandstones that we have been getting to know so well. Some of it went out to the ocean. All of it left this spot to be this rock exposed. That's not the end of the story here for Shelburne Falls. Something else happened. Glaciers happened here. And most importantly, glaciers melted. Now, when a 5-mile thick sheet of ice melts, it releases a lot of water. The water is moving really fast and it's falling down really abruptly. And sometimes when it falls, it hits the rock. And as it hits the rock, it might start to swirl. And if it hits the rock and it starts to swirl and it has some sand, it might drill out what we call a pothole. That's what we're looking at here. The water falling off the glacier acted as the drive train for a drill. The sand at the bottom acted like a million tiny drill bits, and it scoured out a circular hole in the rock. Right I'm standing next to right now is actually two. One large pothole joined to a second smaller pothole over there. If we walk around, you'll see lots and lots of potholes, and if Mr. Ward turns the camera that way, you'll find that you're looking into a gigantic pothole. All of the potholes carved by glacial outwash, drilling down with the aid of sand into the rock. There are several pages in your fieldwork journal that you can fill out while you're here. You can sketch potholes, you can sketch the waviness of the gneiss, you can sketch the overall scene. Be sure to talk a little bit about the story I've just told you while you're sketching. Have fun. So, what can happen sometimes is that you might unfortunately be swallowed by certain of these potholes. That's okay. I want to point a couple of things out about this site though. The potholes can be dangerous. The water can be particularly dangerous. It's going to be really important to stay with your group while you're here and move from place to place in a group. Do not run off by yourself. You can very easily slip. You can very easily get yourself in some serious trouble. Pay close attention to your chaperone and stay together.
Now, one of the very helpful and considerate things that Shelburne Falls potholes do for us is they trap a lot of really cool rocks. Now, a number of students have asked me, if I find a really cool rock, can I take it home with me? Well, in fact, sometimes you can. And you might just find yourself some pretty cool rocks that have been washed down from the metamorphic rock outcrops in the mountains to the west of us and down the river, and then they've been trapped in these potholes where they're going to stay until enough current comes through and washes them on. Here's a particularly weird one that I found that I'm certainly going to take home with me. And enjoy yourself in this little rock hunter's rock trap.